Okay, it's working. Good. Okay, so let's take a look at what it looks like in a graph. So distance versus time. If you're accelerating, so that means that your velocity is increasing. And remember, we said if it's constant velocity, distance over time looks like this, right? Same distance, same amount of time, right? Straight line. On the other hand, if your velocity is not constant, it will not be a straight line. Let's say it's acceleration. What's it going to look like? Yes?
Is it like low and then it goes up?
Good. So it's going to be a curve going up, right? Because your distance over time is continually increasing. So every time segment that goes by, you're getting more and more distance. On the other hand, so this is what? Acceleration, right? On the other hand, if you are decelerating, what's that going to look like? It's going to look the opposite, right? So distance over time is going to decrease, right? Of course, right here, you're doing a constant speed, but that's okay. Now, on the other hand, we don't have to just do distance over time. We could do speed versus time, right? So if it's speed versus time, then what does this represent?
Constant speed.
Constant speed. That means zero acceleration, right?
Yeah.
Unless you're changing direction. Good job, Smith.
But it's not indicated.
Good. On the other hand, let's see, what would this be?
You're accelerating constantly.
As a constant acceleration. What about this one?
Constant deceleration.
Constant deceleration. Okay, well, you guys are tricky here. What about this one?
You go slower, you go faster, a little bit slower, then you go faster and faster and faster.
Okay, so you are constantly accelerating, right? Your acceleration is changing all the time.
Yep.
But it's not a straight line, so it's not as easy to figure out, is it? This one you might use instead. Remember we talked about instantaneous speed? We would talk about instantaneous acceleration. Bam, what's your acceleration right then? So it's kind of like you would be adjusting the gas pedal, as you guys mentioned before. So you press it a little bit initially, and then you keep pressing it more and more and more as you're going faster and faster and faster. Right? So in this case, you're going faster and faster and faster. Here, you keep increasing the rate at which you're increasing your speed. How about them apples?
I like apples.
Like those apples? Now, a taste of the future. In the future, we'll talk about the acceleration due to gravity. Gravity is a pulling force. We've talked about it before last year with astronomy, right? And a little bit with oceanography. So acceleration due to gravity, it's measured as right about 9.81 meters per second squared. So now you know what meters per second squared means. It's just velocity over time. So that means, let's say you were to,
Jump off the entire staple.
Sure, or just, when you do the egg drop, you could drop it from the top of the gym, let's say. So you take your little egg and you drop it, so, yeah. So after 1 second, how fast is that thing going?
9.81 meters per second.
9.81 meters per second. Right? So let's make it easy. Let's just round it to 10. What after 2 seconds?
20 meters per second.
20 meters per second.
What about...
After 3 seconds?
30 meters per second.
What happens when it hits its terminal velocity? That's what I was going to say.
Terminal velocity. Interesting.
Eggs have a high terminal. Eggs have a very high terminal velocity because they're